Okay, today we are here to talk more about hypothesis testing, this time testing a claim about a mean. This is one of the more important things that we're going to do. It's actually really similar to testing claims about proportions. We are pretty much only going to look at what they're calling part one here, which is the thing that comes up more often, which is when you're doing this without knowing the population standard deviation, it is pretty rare to actually know that population standard deviation. So we're going to be working from knowing the sample standard deviation. So if we want to test claims about a population mean with sigma not known, we're going to do that with formal hypothesis testing. Some notation again, we have n as our sample size, we're going to have x bar as our sample mean, s as our sample standard deviation, and mu sub x bar as our population mean. Our requirements this time, we need a simple random sample, and either or both of the conditions satisfied that we know the population is normally distributed or n is greater than 30. There's a complicated formula for finding a test statistic here, t value. We are not going to be using that formula because we're going to be using StatCrunch. If you wanted to find critical values, you would use the student t distribution table that we previously used a few sections back. It's table A3 in your textbook. And the degrees of freedom are once again n minus 1, so 1 less than the sample size. So we have this normality requirement. If the original population is not normal, then we need n greater than 30. Sample sizes 15 to 30 are sufficient if the population distribution is not very far from normal, like it's relatively close. This is a little squishy. And then pretty much we're just going to decide for this text that if n is greater than 30, we're going with a normal distribution regardless of how far the distribution departs from a normal. So some things about the student t distribution. Again, we talked about this distribution a few weeks ago. It's different for different sample sizes. The student t distribution is generally shaped like the standard normal. It's just wider and has greater variability. That's because we're using S instead of sigma, the sample standard deviation, instead of the population. It still has a mean of 0, like the standard normal. The standard deviation of the student t distribution varies with the sample size and is greater than 1, so it's not 1 like the standard normal. As the sample size gets larger and larger, the student t distribution gets closer and closer to the standard normal. I think we had that exact same slide just a few weeks ago. Example we're going to go through is about adult sleep. The author obtained times of sleep for randomly selected adult subjects included in the National Health and Nutrition Examination Study, and those times are listed below. N equals 12, x bar is 6.8333333 hours, and the standard deviation is 1.9924098 hours. A common recommendation is that adults should sleep between 7 and 9 hours. Use the p-value method with the significance of 0.05 to test the claim that the mean amount of sleep for adults is less than 7 hours. So we have our requirement check here. It is a simple random sample. The second requirement, that the population is normally distributed or n is greater than 30, we're not 100% sure on this. So we do a little check to make sure that the sample data don't look too far from normally distributed to see if we can actually do this. So if you do a histogram, you can see it looks relatively normal, and then they went a step further and did this normal quantile plot, which is something that you can do in StatCrunch. We did it previously, and you can see that it also looks approximately normal there, pretty close to the line, so they're going to say this is satisfied. Most of the time when you get these problems, it's going to be a little clearer that yes, I have a sample greater than 30, or yes, I know the population's normal. This one's kind of on the squishy side, but they're going to go ahead and do it. So we go through our hypothesis testing that we did the last time. So step 1, the claim is that the mean amount of adults sleep is less than 7 hours, becomes mu is less than 7. The alternative is mu is greater than or equal to 7. Mu is less than 7, does not contain equality, so it becomes the alternative hypothesis. The null hypothesis is that mu is 7 hours. So our setup is H0 is mu equals 7 and H1 is mu is less than 7, which was our original claim. So we have our sigma value as 0.05, and we're making a claim about a population mean. Our sample statistic we're going to use as our sample mean, and we're going to use the t-distribution because we don't know the standard deviation, right? That's when you use the t-distribution. They go through the steps here to calculate the t-value. We're going to do that in StatCrunch. You can see they got negative 0.290. They show how the results of doing this on a TI-84 calculator also. The p-value is 0.3887, which is greater than the significance level of 0.05, so we failed to reject the null hypothesis. So you can conclude that there's not sufficient evidence to support the claim that the mean amount of adult sleep is less than 7 hours. So let's go ahead and take a look at doing this in StatCrunch. You go to t-stats, one sample with summary. And our setup here was we had a sample size of 12, a sample mean of 6.833333333, something like that. And our standard deviation was 1.99240984. Our hypothesis test, our null hypothesis was that it was 7, and we are claiming less than 7. So compute, you can see degrees of freedom's 11, our t-stats negative 0.28977, and our p-value is 0.3887. We were looking for a p-value of less than 0.05, so that didn't happen, so that's why we could not reject the null hypothesis. Now, if you wanted to do this with comparing the t-stat to a critical value, you could do that. Like in the last section, you could compare this to a value from the table that lined up with 0.05 being in the left tail. That would require you to look at the table in Appendix 3, the table A3 in your textbook, which is one we've used before. It was the t-stat table. It had 1 and 2 tail values that would line up with certain amounts. So you would go in there and look for the one that came closest to putting 0.05 in the left side tail and compare to that. It looks like they actually went and looked at that table and found that the value that you're looking for is a critical value of negative 1.796. Since we only had a value of negative 0.290, that is not inside that left tail, so that's why we failed this time around. You can see that we ended up way over here at negative 0.29, which doesn't even come close to where we needed to get the negative 1.796. Again, unless some sort of problem specifically required you to use that method, it's much easier just to use the p-values, since they are easily spit out by StatCrunch and you don't have to look at tables or anything. So that's the way that I would go. All right, that is where we're going to stop this video.